Okay, thank you very much. I hope you all enjoy the days, and I hope you all are healthy. So I go directly for my presentations. My name is Irendra Rajawali. People call me Raja. I'm now serving Encon Engineering and Adaramara, a startup company in Indonesia. While also actually I'm a researcher at some universities. I'm trained as an ecologist, but also my first degree was in civil engineering. I would like to share with you, I will take 10 minutes of your time maybe, but I would like to share with you how we work together with Supermap. We work with GIS, and we combine with big data and artificial intelligence for, I would say, infrastructure 4.0, where we use it for assessing the speed train railways constructions for monitoring the system. So then we have a very, as the previous speaker spoke, we have a very precise and accurate data on the progress and on the achievement of the constructions. So I would start with this one, and then moment. Sorry, my computer. Sorry. Yes. So I hope you can see my. That's it. Sorry. So we use drones. We enter the. I put the number 4.0. I use this term Industrial Revolution 4.0 because it's characterized by data. The first point, the Industrial Revolution 1.0 is 1784. We know all that when the industrial revolutions began, the mechanicals, these steam machines was discovered, and then 100 years after the electricity, 100 years after the 1969, then you have the internet, and then now we have the big data. So our questions was our challenge was how we can monitor the constructions in the very efficient way, but yet very precise and very accurate. So we use the drones. Why we use drones? Because it gives you more precise aerial data than the satellite images, of course. But I don't want to say that drones will replace satellite images. Not at all. It's a combinations between satellite images and drones. But we use drones to monitor the projects. Why drones? As we can see in the right picture in your right hand, you can see that there are a lot of there are big markets opportunities for drones, especially in the different sectors. The infrastructure sectors especially is really interesting, and it's really promising. And you can see also the other sectors, and we have a lot of agriculture, transportation, security, media, and entertainment, etc., etc. So basically, we combine the GIS, the drones, and the AI to provide our clients, to provide our partners, to provide research with a system which can help us to determine the precisely and accurately the progress of a project. This is the project that we are dealing with. One of the projects. It's a speed train from Jakarta in the western part of Java. Well, you can see, and to Bandung, the city south of Java. You can see this here. You can see here in the bottom right of the maps, you can see from Jakarta to Bandung, north to south or south to north. It is 145 kilometers long. So it is long. And the thing is, this is a project between Indonesia and China. So we will build a train with a speed of 350 kilometers per hour. So this distance will be will be, covered in less than 1 hour. That's the idea. So it has to be precise. It has to be, it has to be really precise. Otherwise, bad things or these unwanted things can happen, right? So then we have to monitor the project very, very, very precisely. So we use the drones. The drones that we are using is, well, the picture in the left-hand side. You can see this is one of the types of the drones that we use. These are VTOL drones. We fly these drones along those lines to monitor the project, the constructions. So with these drones, we carry the camera, high resolution camera, and this drone is equipped with GPS, etc. And it flies autonomously. So we only have to setting up the route of the drones to fly, and we wait for the drones until it finishes, and then and then we have the data, and it takes pictures. It takes pictures of those areas. So why drones? Because it's just not possible to monitor the whole projects manually. In the first year, our clients monitored these constructions and projects manually. So they just took pictures rather randomly in kilometer X, in kilometer Y, so in different places. But then they missed a lot of insights. They missed a lot of informations, right? So we decided to use the drones to cover all. So for 145 kilometers, we need only 3 days, up to 5 days to acquire the data. So the data acquisitions takes between 3 and 5 days, and we have the high resolution pictures, and then we stitch those pictures into maps that we all can see in this slides now. So basically, what we are doing and what we are providing is a dashboard containing the data, the spatial data taken by the drones every now and then or regularly. So then, we cover spatial temporality, so we can see the progress over time, over place in kilometer X, kilometer Y. As you can see, these two pictures, the upper one was taken last year, June 2020, and the down one, the lower one, was taken this year, June 2020. So just by seeing this picture, we can already see the progress of the projects, right, in 1 year. And imagine this is only one spot of the pictures of the area of the constructions project. We have 145 kilometers at this scale of precisions, if you want, that we know which one is where and which one is done, which one is not done, etc. So we have, with the drones, we have a pictures, or we have an image with the ground sampling design, or let's say the resolution is around 5 centimeters per pixels. You can see later on, if I zoom this picture, you can really see even the materials, the constructions materials, if you want. So this gives us a lot of information, a lot of opportunities to monitor the projects very, very precisely and accurately. And we use also a GPS, of course. Then we can really examine the construction's progress based on location. So if our clients needs, like, let's see kilometers 38, then we can go there directly and then see and compare the changes and the transformations, and then the speed and the progress of the projects, right? So this one goes to the dashboard, and we work together, we collaborate with Supermap on creating this dashboard, almost real-time dashboard that our clients can see directly, and almost real-time, the progress of the constructions projects. Furthermore, how AI enters this dashboard or this project. I have three pictures here: the substructures and the superstructures of the constructions. The substructures of constructions, you have the piles. We have the piles, right? And the superstructures of the constructions, we have the pile cap, right? So we train the computer, we train our machines, our computer with the algorithm. Also, we work together with Supermap. Besides, also we develop our own algorithms. We train our computer to recognize these features in the picture. For example, we need to know if, yes, there is 100 piles have been put on the earth. But how do you know? Do you want to walk 145 kilometers and check it one by one, while one pile might have around 12 piles, and there are hundreds of pile caps. You can't check it manually. So we train the computer to recognize the images, to recognize the features in the images. For example, in these slides, you can see we train the computer to recognize, hey computer, hey machine, please, if you find this kind of thing in the picture in the next kilometers, then count it as piles, right? Or if you find features like this, like the bottom pictures, the bottom ones, yeah, then count it as pile cap. And computer, please count for all 145 kilometers. Please count it for me. Like how many piles there in which kilometers, and how many pile cap are there in different kilometers. So basically, we train our computer with the data, with the more clever, the more data we use to train our computer, the more clever the machines are, right? And also we push the efficiencies. Why? Because once the feature defined, the algorithm itself will count all the components, all the interest, and all the important objects that we are interested in automatically. So then for 145 kilometers, we just have the numbers with the high precisions, with the high accuracies that we believe it. And again, the more data you feed the computer, the more clever the computer is. So we have a high accuracies. With this system and working together with Supermap, I would say again, we have a really, I would say, interesting and useful and pivotal dashboard for decision makers to check the progress of the projects, of the construction project, and also for the finance persons. For example, if the contractors put their invoices, then they don't really have to check to the field. They just see the dashboard and they know, okay, 100 piles have been put on the earth. So they just count it. They just see the dashboard. That's the idea, and it's still working. And you can also check. We also train the computer. You can see it. We also train the computer to recognize different kind of features, construction features. For example, we train the computers to recognize the girder block. We also train the computer to measure or to recognize the pile groups, etc., etc. So with this system, again, we want to provide the decision makers with data, but not only data, with informations, with knowledge even, that is precise and that is accurate. That's the idea. So just to close, of course, we use the same algorithm for the other projects. We don't have much time, but what I'm showing you here is the project in the constructions. Me, myself, is an ecologist by training. I use it also for the forestry, and we use also GIS, and we work with Supermap also to develop this dashboard, this platform, using GIS, drone, and AI for decision making. So just to close, what we found so far is we have we can gain high efficiencies on monitoring the projects, the constructions projects. We have a high accuracies and precisions, and we have the spatial temporality of the data. So the data is not the dead data. The data is alive because it's taken from time to time. So we see changes. So dynamic data, if you want. And also, we learned a lot that these combinations between hardware, software, and brainware are important, very important. You have to teach the computer, the AI one, the machine learning one, with the knowledge that the human have so far, so the brainware and the software one, and you have to put it in the GIS dashboard, like the Supermap provided us with. And of course, you have to have the hardware. In this case, in our case, it's a drones. We also put the thermal camera in our drones to monitor the constructions, etc. So this is what we learned, that the hardware, software, and brainware are very important. One cannot go on its own, and it's reliable in our opinion. And we also learned that the GIS needs to go way forward into the GIS if you want GIS 4.0. What is the 4.0? I would argue that it's not only data, but the challenge is how to change the data or transform the data into informations, how to transform informations into knowledge, knowledge into insights, insights into wisdom. So from data to wisdom, and then of course actions. And of course we can discuss more later on what about the efficiencies in terms of economic efficiencies in terms of time, in terms of everything else. So thank you very much. I would close with these statements. We all believe that the ultimate sophistication is simplicity. So we try always to be simple because it's just sophisticated. Thank you very much.